All right, we are looking at notes 3-4 today, which is going to be rational exponents. Before we get into the whole meat of everything, we're going to review some vocabulary stuff. So the first one is degree. So degree is that tiny little number that sits above the little radical symbol, which I guess we should go to radical first for that one. The radical is the actual part for it. So it's the actual radical symbol. That's kind of what we used probably have called the square root symbol before, but square root is only whenever it's actually the degree of 2. So this one is making sure that we have there, and that length of that horizontal bar is important. I need to know that square root of a plus b. The same way if I had a fraction bar and I had a plus b, I had to make sure that it's all the way underneath it. It's the same thing with this radical symbol. With degree, it's got a few different names. They call it degree, they call it an index, or sometimes they'll call it the root number. All of those things are the same. Basically, it's saying that that's a degree of 3, so we would call it a cube root. It's the number of times that the radicand is multiplied by itself. And so if I have 2, it means I have a square root. 3 is a cube root. After that, they just call it 4th root, 5th root, 6th root, 7th root, and so on. Now the radicand is everything that's underneath it. So for this little one, it'd be a plus b is my actual radicand. That is the thing that you're actually finding the root of. So we're going to look at converting between the two. So we're going to look at some things that are going to be in radical form, where you're going to have the actual radical symbol and some numbers in the degree, a number in the radicand, and even a number for a power on it. Or maybe it's just the radical symbol and a radicand. But the key there is that they all have the actual radical sign for it. Whereas with exponential form, we're going to look at making them into fraction exponents. So the key to converting is to think about the degree as your root. Think about, we call them these a cube root, a square root, a 4th root, and it's like the roots of a tree. So on the bottom, I'm going to have the root. And then on the top is going to be the power. And so when I can rearrange it, the 7 stays inside, the root goes into that right with my little root symbol, and the power is outside as an exponent. So this is on our formula card, on our blue formula card, which we should have out right now, and it shows us that a to the m over n power is the same thing as the nth root of a to the m power. And I want us to go ahead and add a little second thing on there. So this is also the same thing as the nth root of a, and then parentheses around it, raised to the m power. Those are the same exact thing. It doesn't matter where I put that m, is if a is the only thing inside. If I got multiple stuff, that's when it's going to be tricky. So if we're looking at our first one for it, exponential to radical form. 3 is my root, so it goes with the radical symbol. It's a cube root. 4 stays inside my radicand, and then I have the 5 as the power because it's sitting on top. I also could have wrote this as the cube root of 4 raised to the 5th power. Those are exactly the same. Next one, 2 ways of doing this is I can keep that 4th root. Notice no matter what, the 4 is staying with that radical symbol. It's the 4th root. Notice that 5x is inside that radicand, the same way it's inside the parentheses. And then they dropped it down here to where it was either, since it's that negative, we know that it would have to drop down. So it would have the 1 over for it. But with this one, I could not write it like that with it inside, because there it's not telling me that the 5 gets that exponent as well. So this one I can't write with it inside. It's got to be written with the parentheses and the power outside. Last one, again, I want you to see 3 on the bottom, 3 with my root symbol. So cube root 7 to the 4th power, and again this can be written where I've got cube root 7 inside, and then I can put a big old parentheses around it and raise it to the 4th power. So that's taking it from exponential form to radical form. We're going to look at what happens to take it back the other way. So they're giving me the radical form, and this time I don't look like I've raised something to the power, but remember that I can take anything and raise it to the power of 1. My root is going to stay down on the bottom for it, and then I have that 1 that's sitting on top. So this square root, because it's index of 2, turns into 3 to the 1/2 power. Now this one is what I was talking about earlier. This 5 isn't to the k as well. So this is all by itself. So it's not all raised to the 5th power, only the m is. But I could say that all of this is raised to the 1st power. So I keep everything that's inside my radical, so my radicand, together. I made sure that my root was on the bottom of my little fraction bar where the roots of a tree are, underground. And then I took and made that 1 sit on top. Last little one. This one I only have the G, so it can go either way on it. I want to make sure cube root, so 3 on the bottom of it. And I've got the 2 sitting on top because it's raised to the 2nd power, so it can stay on the outside. Since it's only G in here, then I can put this through. So the key to going through and getting these things converted, again, is to look at your root staying with your root symbol. So the roots are just like they're below ground, are going to stay below on that fraction bar, and then it's going to stay with the root or radical symbol. All right. At this point, we're heading to assignment 3-4.